Hello, everyone. My name is Will Wilson, and a big thank you to Gray and to Mackenzie for inviting us to speak with you today. It is our pleasure, and we're very excited to share some information with you today. So as I said, my name is Will. I'm an application engineer, and I'm based out of the Novi, Michigan office and work with most of our automotive and off-highway customers on the areas of data analytics and big data and doing analytics stuff with MATLAB. So that's a little bit about me. Some quick level setting about today's talk is really, I want to accomplish three things. I want to inform you of some new capabilities, kind of let you know what we've been up to with regard to MATLAB and Databricks. I want to spend some time in an example, kind of showing you how it looks and feels. And really the intended outcome is three things: increased awareness, who to talk to get more information, and hopefully to inspire you to think about what else you can do. The hope here is that this opens up new avenues, new doors, new opportunities for you to do more with the data that you already have. So in case you don't know who we are or what we do, we are the MathWorks, and we make kind of two key softwares. We make MATLAB and Simulink. Many people are familiar with MATLAB, but maybe from some time ago, and maybe used it in university and haven't seen it since. And what you'll see today is that the platform has evolved greatly over the last few years into the space where we can do a lot more with analytics. So MATLAB is the software, that's the programming environment. Simulink is a graphical design environment for designing systems, both physical systems like plant models, as well as control systems, really with the intent on taking that model and generating typically C code that would live on some embedded device somewhere. And then within our ecosystem, we have what are called toolboxes, which would be analogous to libraries or modules in other languages. They cover a huge range of application areas. And just by example here, what I mean by that is, if we look at the products page, there's toolboxes for all kinds of application areas, from things like optimization to reinforcement learning to signal processing, image processing. And it's also organized by application space as well. And so this is kind of the area we play in. We play across almost every industry, from auto, aero, finance, medicine, and our tools are used in lots of different ways. So going back here, when I talk about MATLAB as a platform, what I'm really getting at is not all the little details in here. I'm getting at the fact that there's a workflow behind this, that there's the notion of you have to start with data coming from somewhere, and you have to deliver something in the end. And along the way, along the journey, there might be some discussion about AI, there might be some discussion about Simulink, building models, simulating things. The end result might be a software artifact, maybe some C code, maybe you plug into a dashboard somewhere. Regardless of what you're doing, there's a workflow there. And we view the MathWorks platform as enabling that workflow, wherever your data might be, to wherever it has to end up, wherever the artifact that you generate or the end result that you want to get to. We try to help you connect the dots to get there. So that's really what this slide is talking about. It's not just, MATLAB is not just a desktop tool. It's a tool that can be used in the context of engineering workflows. So our relationship with Databricks goes back to 2019. And it's really focused on, like I said, helping you take what you already have or what you want to do and run that at scale on the cloud. There is a beautiful collection of APIs and an ever-expanding set of use cases that Databricks has exposed. And we've tried to help connect the MATLAB platform to those APIs to really help give you the freedom of choice to tackle these problems in a way that you're most comfortable with, or that you determine is the most optimal way to approach that. And that includes things like DBFS, MLFlow, DBConnect, and so on. And we envision that this is going to continue to grow and evolve as new use cases come about. So I tried to take all of that and put it into a slide. And if I'm going to be totally honest, I would say that this is probably not a definitive list, because I can't anticipate everything you might want to do. But what I can tell you about this, going through this and building this slide for myself, what I learned from this is that really, I see it as kind of two main buckets. If we take this slide and we imagine that we divide the world in half here, where the upper half talks about this notion of I need to do something interactively. I'm exploring, I'm trying out ideas, I'm doing some at-bat type work. A couple of the APIs come to mind for me for there. The SQL API, where I want to use the MATLAB database toolbox and kind of treat the data on Databricks as just a database table, and I want to interact with it. This probably isn't going to involve any Spark on the user end, and it's going to be for more kind of discovery type work. Okay. Databricks Connect says, nope, I want to fire up full-blown Spark and just run this stuff against massive sets of data. You'll notice in the third column, a lot of the potential use cases I listed are overlapping, because I do believe they are. And I believe there's more there that I couldn't anticipate. But from a where do I get started, how do I think about this perspective, you got to know that there's a collection of APIs that help you do different things. And I envision people are going to do really kind of interesting and cool combinations of this as well. It's not like you just pick one and stick with it. And then on the bottom half of this chart, this is what I'm calling kind of batch mode, or more like production mode, where I don't need to so much interact with the data. I just need to run jobs, or I need to run code against this stuff. We kind of envision that when we get to the Simulink side of things, which is out of scope for today's talk, but if you want to talk about running Simulink or bringing a Simulink model into the cloud and running against huge data, we envision that that's probably going to happen here. And we're actually actively working on building out some examples on how that might look. But this hopefully gives a landscape of what's out there. I'm going to talk to some of these things today in the demo, but I wanted to give you a sense that there's a very rich collection of APIs, and again, really designed in the spirit of giving you freedom of choice of how you want to approach these things. There is no one best way to do it. There's going to be whatever works for you and is efficient for your workflows. So we're going to talk about the idea of predictive maintenance, or really using all of this amazing data that you have to try to be smarter about how we can use it. And the example we're going to talk about was actually built by a dear engineer, Megan Kosmatka, who's an exceptional engineer. And she was wanting to know, if I look at data from turbos in the field, can I predict something about the state of health of these systems? And so that really gets at the topic of predictive maintenance, being smart about using your data to talk about things like machine uptime, or when you think a machine may need repair or service. She tackled this problem using something called Rainflow counting. And without getting into all the details, I put a link here to the doc on this. It's really looking at counting fully reversed bending cycles. And based on the number of cycles, you can say something about how much damage has been accumulated over time. And so the question is, great, we can do this locally. How do we do this, against big data sets? And that's really what this got into. So I'm going to talk a little bit about that in the demo. But before I leave that, Megan and Arvind Hosekar, who is our MathWorks chief solution architect, actually presented this case study at the Spark AI Summit just last year. And I put a link here to the talk. It's an excellent talk. If you don't know Megan, you should. And I would suggest that you should take a look at this talk, because it's really, really good stuff. So without further ado, I'm going to jump into MATLAB, and we're going to take a look at how to actually do some of this stuff. So what you're looking at here is the MATLAB desktop, and specifically I'm showing you something called a live script. So this is a newer way of working in MATLAB. It's a notebook style of working, and it includes all the normal MATLAB code, in addition to rich formatting, hyperlinks. I could add pictures. I could add whatever I need to add to tell my story. So instead of sending you a block of code, I could send you a live script that you could run, and you could also just read it like a document. So a lot of utility around this. So I wanted to basically break this into 4 parts. I want to start with, hey, my data is in Databricks. Now what? I want to talk about data itself and the fact that things aren't always clean. I want to talk about this predictive model, this Rainflow type model, and then ultimately how we would deploy this on the cluster itself. And then I left some time at the end for Q&A, so I really want to get through this and then open it up for discussion and Q&A. If you want to jump in, go ahead. I don't have any problem with that, but there is going to be time at the end for questions. So the first thing we're going to do, and I guess before I start running MATLAB code, let me show you on the back end what's going on here. So we have a Databricks cluster. I just spun up a kind of a multi-purpose cluster. This is our little test environment here. So I have a cluster that I spun up, and I'm going to be using this for our work. And in terms of data, I know our data is not exactly the same as what you have at Deere, but we have database tables. We only have a single database today. We do have a small collection of tables. I know the collection of Deere is big, so you'll see a whole bunch of tables, and I would guess they're probably going to be broken out by many databases. And then in our DBFS, we have a series of, I switch over to this, we have a collection of folders that we made, and we were able to just kind of put different artifacts in these folders. So when I talk about tables, this is what I'm talking about. When I'm talking about folders, this is what you'll see for the purposes of our demo. Let's get back to MATLAB. So the first thing you're going to want to do is connect MATLAB to DBFS. And so we'll set this up with our Databricks connector here. And then we can do things like, hey, what files do we have? I can look into DBFS and I can list out all the folders to get a sense of what do I have to work with. And in particular, I'm going to be working with data in this folder here. So I could do a list on that folder and I can see, oh, look, I have a Parquet file in here that I'd like to use for my demo. I'm showing one file here today, but there's no reason this couldn't be hundreds or thousands of Parquet files as well. And then if you wanted to know more about this, about the Databricks object, you can call methods on it. You can see what else you can do. And this is going to be really handy if you need to upload files to DBFS, maybe download files. This isn't like necessarily data files. This could be things like jar files or configuration files that you want to kind of move back and forth. At this point, we're going to get into Spark. So the first step is to import the ML Spark library. And this is what basically allows MATLAB to start to interact with all this stuff. We'll start up a Spark session. This is a shared Spark context. And from this Spark context, we'll start to inspect some of the data and kind of work around our data set itself. So the first thing I'm going to do, I'll just run these. I'm running these section by section to walk through these. Is I'm going to create a data frame. And if you recall, I had this. Somebody told me, hey, I put some data in this folder for you. I'd say, okay, no problem. I'm going to check out what's there. I'm going to see that it's a Parquet file or perhaps a collection of Parquet files. And then I will just do kind of the normal create a data frame stuff here. So I'm going to read Parquet. I'm going to infer the schema, and I'm going to load it from wherever I said it, the files are sitting. Now this can also work with Delta. I'm showing Parquet as this example, but Delta is in play as well here. And then for me, because my background is mechanical engineering, so I'm very much, I need to see it before I can kind of work with it. I tend to do a lot of discovery type work. So the first thing I might do is take a peek at, well, what exactly is in this file? And so the normal sort of way to do this with Spark would be to just show or perhaps do a limit. And you can see I have some sort of table here. Every row is an observation in time. I've got some signal and then some value. And then there's a bunch of other stuff here like machine type and so on and so forth. So I get a sense of kind of what I'm looking at. If I wanted to do the same thing with MATLAB, we've implemented a method called table, which converts the data frame to a MATLAB table. And MATLAB tables are my absolute favorite data type. I have to have a really good reason not to be using tables for pretty much everything I do in MATLAB anymore, because they are such a natural way to hold kind of mixed tabular data, much like what you see right here. So I've got a timestamp column, I've got some string column that's signal name, and so on and so forth. And MATLAB tables are really, really powerful for that. If you want to know more about any of this stuff I'm talking about, if you look up here in the right-hand corner, there is the documentation little search bar, and this is kind of like a little MATLAB angel sitting on your shoulder. If you forget syntax or you want to know more about a certain topic area, you could come in and say, well, tell me more about tables. So you can look at tables. This is going to pull up the MATLAB doc, and we go up one level here, and it says, oh, tables. Yeah, it's got named columns of different types. And then you can see that there's a whole bunch of other functions that you can do on tables. And we're going to talk about this more in a minute, but things like, what do you do if you have missing values? Or what if you want to, bring tables together. There's all sorts of things in here that makes working with and munging data very, very intuitive. And you don't get this with matrices or cell arrays or structures. So this newer data type of MATLAB tables can be really powerful when we talk about doing analytics. And that's why everything that I'm showing here today is I'm kind of casting to a MATLAB table. And then just another example, what if, I've got this data, I'm kind of exploring, I'm new to it. Well, what all is in this thing? What am I looking at here? If I assume that I have some set of signals, what's in there? So I can do a distinct on that, which would be the equivalent of calling like unique in MATLAB. And what I've done here, this is actually running a Spark job on the cluster and then bringing back only that unique set of tables, or sorry, that set of signal names. So I'm not actually doing any of this computation in MATLAB so far. I'm basically setting up the Spark code and telling it to run on the cluster as a Spark job. And if we looked at the cluster and looked at the Spark UI, you'd actually see that in there, that these jobs kind of get triggered. And then I could do something like count the number of signals. So I say, oh yeah, this table is representing, I have almost 200 signals here. And then before I do anything else, I could do some sanity checking. I could say, well, is the thing or are the things that I'm looking for, are they present in this data set? Because I may spend all this time writing code or developing an algorithm only to find that I have some data quality issue where the data is totally missing or it's totally wrong. And then I've wasted a bunch of time. So for me, kind of as an AE doing this for a while, I tend to put these little kind of checkpoints in place to make sure that what I'm looking for is there and things make sense as I go along. I build this up over time. And then the other kind of best practice that I've found is that many times you don't need all of the data to do a specific analytic or specific study. So I tend to try to shrink things down as much as possible to only touch the data I have to touch. And so with a data frame, you can combine things like select and filter. Maybe I only need a couple of columns out of the table. And I think, what did the original table have? The original table had, I don't know what this is. Let's call it 20 columns. So I've thrown away or just ignored the things I don't need. And I'm only pulling back, or I'm only going to consider maybe these columns. Okay, so that's a way to kind of be smarter about what data do you really need for a given analytic. And you can do the same thing. So everything I've showed you so far is with just kind of like normal Spark. If you prefer more of the SQL expressions, you can do the exact same thing. So if I show like this thing here is exactly the same as this in terms of the output. So you have, again, freedom of choice of how you want to express these things, but they both work, and you can implement wherever makes more sense to you. And then if you wanted to add additional stuff, I wanted to show everything, but I had to put the brakes on at some point. The idea is, and I hope you get the point here, you can add additional criteria to this if you want to add, I don't know, some sort of time window around this, select data between this and this. You can go nuts with this stuff, and it could look like this in terms of different, only want data from a specific machine, or maybe you want to look at, well, what time range am I actually looking at here? You can do all of this with this syntax. Quick side note about database tables. When I first got into this, I was like, well, how do you know what tables are there? Because there could be a bunch of them. You can use the show tables command to get a list. And it's my understanding that you guys have a bunch of tables at Deere, and you have something else called it's not a data dictionary, but some kind of data catalog that talks about this table has this data, so on and so forth. So maybe that makes it a little easier on the Deere side. But I could see someone coming into this and you're told, hey, your data's in a table, let's go. And you're like, well, what does that mean? So this can help in kind of discovery about what that is, and at least you get a sense of what's there. I only put that because I struggled on that myself, and so I thought maybe this would help somebody kind of down the road. So now we get into visualizing data. Again, as a mechanical engineer, I need to see this stuff. I need to kind of take a look at it. And so what I've done here is set up some code, go back to the data frame, and pull in the first X number of rows of the data frame. And I've done this here. In this case, it's 571, but I've put what's called a live control in my live script. And a live control is things like a slider or a dropdown that allow you to interact with your code and do different things. So if I wanted to see, I don't know, let's say I wanted to see the first 670 rows, as soon as I let that go, that kicks off another Spark job to expand how much data I brought in and then visualized. So this can be really, really useful in terms of just kind of taking a peek around, getting some sense of what's there. Now, I certainly wouldn't set this up to bring back 10 million rows of data, but if you wanted to interact with this and do it in a way that's kind of intuitive, this can be a really cool way to do that. MATLAB plots are fully interactive, so I can pan and zoom. If I wanted to zoom in here and just take a peek, I can do that. If I was wondering, well, what is this upper point? I can grab a data tip and I could get a sense of what's there. Maybe I need to know what that is so I can build some sort of a detector function. So I can zoom right in and check that out, just have a kind of a conversation with my data almost. The live script stuff, the live tasks is going to be on the insert tab, and you've got tasks, which we'll talk about in a second, but the controls are here. This is where I get that slider or the drop downs, whatnot. So that's how you would insert that little widget into my live script. Now let's get into the nitty gritty. Data is always clean and happy, right? It's always perfect. No, I said nobody ever. Hopefully there's a process to ingesting clean data as we go, but I think as engineers, we know that weirdness happens. And one such example, this is real data from our fleet, our MathWorks fleet. We log data from our vehicles, and in the hope of kind of using that as some fleet analytics demo. And we actually had a trip, and I didn't make this up. You're looking at vehicle speed versus time, real data. And so I'm metrically challenged. So I think about the world in English units, but basically 80 kph right here, this is about 50 miles an hour. And 180 kph is about 100 miles an hour, okay? So we're just, driving along, heading out to the grocery store, going to get a coffee, and we automatically accelerate from 50 miles an hour to almost 100 miles an hour and back down in 1 second. That would hurt a whole bunch if that was true. And so we clearly see something's going wrong here. My gut tells me this is spurious data, but because this isn't my first time around here, I know that I can't just throw data out because it looks like an outlier, because we all know that that's not good engineering. Well, what if I could prove this was an outlier? And in the future, if we had to have a discussion about, well, what did you do here? I'd say, oh, it was an outlier, and here's how I can justify that. Now we're having a valid conversation. And so we have just that in MATLAB. We have ways to deal with all kinds of data cleaning tasks. If I jump back to our doc for a minute, we have a whole section on pre-processing data. And this gets at kind of the pain and agony of stuff that I think all of us have seen at some point, like missing data, like got to smooth your data somehow, or you got to do some normalization. Yeah, you can probably sit down and write most of this code yourself, but there's a whole handful. I think I counted them once, there's over 40 off-the-shelf functions to help you deal with this difficulty. And I'm going to show you one of them today. So this is called, let me run this guy. This is called fill outliers. And so what this is going to do is basically go through my data, and yeah, it's not displaying correctly. In here, there's going to be a whole bunch of options about how do you actually want to tackle this? How do you want to find outliers? And what do you want to do about it? And so in this particular case, I chose a moving median with a specific window. And based on that criteria, I can see, well, this is what MATLAB thinks it's doing. So you can see the kind of the window here, the upper and lower envelope. You can see the center of that moving median. And then you can see the points that MATLAB says these are outliers. And if these are outliers, this is how I filled it in down here. So I can play with lots of different ways of doing this. I can look at things like percentiles. I can apply cubic splines. I have a lot of things I can try interactively. And then when I'm happy with this, I'll get to some point where it makes sense. I can switch over and grab the MATLAB code and pick this up, throw this in a function, throw this in my script, and move on from there. So it allows us to deal with the weirdness that comes with data most of the time in an efficient way. And if we have a design review and somebody says, man, you can't use a moving median, that's crazy. I say, no problem. What would you like to use? I can change that. We can try it immediately and have a good exchange of ideas on that. And so that's really what I wanted to get at here in terms of what we could do. And I typically will bake a lot of this data pre-processing into my workflows, into my pipelines, to check for things like missing data, outliers. Sometimes data shows up and there's giant gaps in time, and I want to kind of group data by time. Sometimes I have to think about resampling data, and you get into trouble when you work with continuous and discrete signals. You can't apply one method for everything, because like if you want to resample gear, there's no gear 1.6. You can't use linear interpolation for that. You'd have to think about a sample and hold strategy, and how do you implement that? So these are some of the ideas around messy data, and I just want to say that the MATLAB is pretty well positioned to deal with that. The next thing, kind of moving into the modeling side now, and this gets at what Megan and Arvin were doing. We've pulled some data down again from the cluster, so we created a data frame, brought it back to work on it. And this is looking at these load reversals. This is looking at counting this rainflow counting, of looking at fully reversed bending cycles to try to understand over a duty cycle or over some period of time, how much damage has a given machine or a given system taken. And so you can visualize this stuff. You can look at these 3D plots. These are all interactive, and spin these around and kind of play with them however you need to, and really try to understand what's going on here. So in order to do this and make this more user-friendly, we took this model. This is a simple model that Megan shared with us, for the purposes of kind of developing this work. And we parameterize this. This takes in a wheel diameter. But you can imagine for any given model that you make, you could parameterize it, according to what you need to do. And then when you pass data into this thing, it does this damage accumulation over sequence. And this is getting at this idea of remaining useful life. How much time do I have left before this thing needs repair or it full on breaks? And if you want to take a look at this, we could look at the model real quick just so you get an idea how this actually works. So it takes in this case, turbo speed, and calls the MATLAB function Rainflow on that. And then we just iterate over that data as well and build up this damage accumulation array. So the next thing I'd like to talk about is deploying this thing. So I'm going to talk through the steps because I want to leave some time for Q&A here. But in this kind of overview is going to apply to things you might want to do as well. So the first thing you're going to do is take whatever model or MATLAB code you have. You're going to compile it into a jar file. So that's going to be step one. So you're going to take your artifact, build it locally, kind of get things figured out, create a jar file, put that jar file on DBFS. And this is so we can execute it on the cluster when we're ready. And that's why I talked about DBFS in the beginning of this, because this is where that utility comes into play. From there, if we were doing this kind of in a batch type idea, we're going to just kick this thing off. We're going to get at the cluster API, so you can create clusters right from the MATLAB command line. And this is a pretty rich API. You can check out what Spark versions are there. You can specify the node types. You can configure your cluster to do what you need to do right from the command line, which is pretty cool. We can make it a MATLAB capable cluster by basically telling it, hey, we want this cluster to be able to see the MATLAB runtime library, so you can execute MATLAB code against that. Once you've set up your cluster, we're going to create a job. And that job is going to be basically connected to the cluster object we set up. You give it a cool name like Jobby McJob. I think there should be points for the coolest name. That should be a metric, I think, at Deere, where if you come up with a really cool name, you get a star or something, because these things can be just really boring. So I would encourage you to, make them descriptive, but have fun with it. Once you have your job set up, kind of, hey, this cluster is going to run this job, you may want to turn on things like email notifications. So here I have set this up to shoot me an email when the job started, if it's successful or if it fails. And I do this because I feel like some of these jobs can take a long time. I want to kick them off, go get a cup of coffee or go to a meeting and come back and see, how's it doing? But I don't want to be checking in on the cluster every 5 minutes. Once that's done, we'll basically set up the task. So here we're going to define inputs and outputs to that jar file that we created. And the jar file really is taking a MATLAB function and creating a jar out of it. So that function is going to take inputs, have outputs. We specify that here. And then we'll go ahead and do the configuration bits where we tell it, hey, we're going to create a task. We're going to give it some name. And then we're going to attach it to the job itself. And then when that's done, it basically comes down to create it, run it, check out how it's doing. So at a high level, those are the steps you would go through to kind of take some piece of MATLAB code, some artifact, get it all set up to run as a job on a cluster that you create. Again, these are not exhaustive steps. There's lots of ways you can connect these different things, but this hopefully gives you an idea of the workflow and the fact that it's pretty straightforward to set these things up. Done with the demo part. I'm going to go back to my slides for a minute and try to wrap this up here, and then hopefully get to some Q&A section. So again, if you can, I do recommend you watch this. It's about a 20-minute talk. It's not very long, but it's really, really good. Megan does a great job here.